Hi everybody, I'm Simon from Viezu and you join me today for our KESS3 OBD training video. So what we're going to do in today's video is show you all the equipment you're going to need typically for OBD tuning, show you the process from start to finish, how we read and write the vehicle, and a number of the do's and don'ts along the way as well. Things like do put a stable power supply on the vehicle, don't try and start the engine while it's writing. So sit back, enjoy, take some notes, and this should give you a very simple to follow user guide of how to tune with KESS3 via OBD. So before we start the job, and let's not rush in and just suddenly plug the tuning tool into the car, there's a few pieces of equipment that we need to make sure that we've got in our kit for today to get the job done properly. Remember, we want to be safe and cautious as we work on any vehicle for any kind of work to make sure that we're not exposing ourselves to any risks. So it's important that one of the do's is that we do have the right equipment to do the job. So first and foremost, for any tuning, we're going to need a laptop. Put this over here. There are minimum spec requirements, and we'll put those in the notes for the video, but basically a middle range laptop, about a 2 GHz processor, decent bit of memory on there. The better the laptop you've got, the quicker it's going to communicate, but generally a middle of the range laptop is absolutely fine. It does need to be Windows based though, just bear that in mind. Next, quite importantly, we're going to need a stabilizer, a battery stabilizer. So we're using the CTEK Pro 25S. This gives us about 12 volts and 25 amps of continuous stable power supply to the battery. We're not trying to charge the battery. It's not a battery conditioner on there. When we're communicating to the car, we want to keep a nice consistent voltage and ampage level through the battery. We don't need those crazy spikes causing any instability in the communication. Now for one of the most important parts of the kit that it's often overlooked by a number of people, diagnostic tool. It's really important that before you do any tuning on a vehicle, you give the ECU, transmission, the whole car really, a good health check. Scan it with the diagnostic tool to make sure there's no underlying or sort of hidden faults or errors in there. The last thing you want to be doing is tuning a petrol turbo that's got an underlying misfire fault, or you're tuning a diesel for performance and it's got an EGR actuator fault in there. You need to know that the car is good, clean, ready to work on. Shiny on the outside, you need to make sure that ECU is shiny on the inside and fault free. Next, extension lead. Whilst it sounds like common sense that we need an extension lead, depending on where we're working on the car, you need to make sure that your laptop has the charger plugged in. The last thing you want is the laptop running out of power whilst you're partway through reading or writing to the ECU. Your diagnostic tool might need a power supply, and of course, your battery stabilizer is going to need a power supply. So these sort of form the core part of your tuning kit. And last but not least, KESS3. We need our OBD tuning tool. So we're going to move all of these around, we're going to take you to the car, we're going to get these connected to the car, and then we'll come back to the kit, show you through the kit of what's in there once we've checked the car for any fault codes, and we've got our stabilizer connected and ready to work. So we've mentioned the importance of the battery stabilizer. We're going to connect to the positive on the battery, and we're not going to connect to the negative, we're going to connect to the earth on the vehicle, just so we've got a nice stable power supply. Notice our CTEK is not currently on. One of those sort of on the do list is we connect the charge points first, then plug in the CTEK. The last thing we want to do is plug in a charger or power supply. You might not be using something like the CTEK, you might be using a different model, different settings and characteristics. The last thing you want to do is have live power coming through the crocodile clips whilst you're trying to connect. We plug it into the power supply, we see it lights up nicely, and in this case with the CTEK, it's really important we see the supply light lit up in orange there, so we know it's in supply mode as opposed to recondition or charge. The supply in this case for the CTEK is a constant power supply, balancing out any peaks and troughs in the voltage and amperage. And we can see there's no codes present at all. We know internally from a software point of view this car's in a good state of health, no underlying fault codes in there. It's great, we can crack on now with the reading and writing process. So let's take a look at the KESS3 kit. First of all, it comes in this really strong, sturdy sort of flight case, plenty of packaging and padding inside. Take off the securing clips and we'll open the box up. As you can see, nice secure foam padding in there to keep all your cables and accessories nice and safe. Now for today, we're doing OBD. There's only actually 3 cables and pieces of equipment we're going to need out of this box. We're going to need our KESS3. We're going to need our USB lead. This is going to connect the KESS to the computer itself, to the laptop. And we're going to need our OBD2 cable. This, of course, connects the KESS to the vehicle itself. And that's it. That's all we need from the kit. Everything else that's in here is for the bench or for the boot mode supported options on KESS3. So all of the cables here you can see in our boot and bench mode training videos. So when you connect your USB to the laptop, you should see the red power light indicated on the KESS3 here, illuminating red. So now we've connected the KESS3 to our laptop, we need to open the software. So we're going to go to Alientech Suite on our desktop. You'll see the software open. We're going to make this full screen just so we can see all of the data on the screen easily. You'll notice at the top of the screen we've got the tool synchronization. This is basically the online check, making sure your tool is in license, it's up to date, everything's working as it should on there. We've got checking firmware version, sort of normal hardware checks. You may also notice on the KESS3 itself that the power light may go off as the data light comes on, as those two lights sort of swap around as it's going through its background checks and that synchronization process. You can see the example here that it's actually updating the firmware. So when you first plug a KESS3 in, it will go through an update process. If you're on the latest version of the software on the computer, that's great, but the firmware will need to be updated as well. If the software on the computer is out of date, you'll see a little window pop up at the start saying, update available, would you like to update? We always recommend that yes, you do update before you start a job. Don't update between reading and writing a vehicle, unless you're otherwise instructed by Alientech support or by the Viezu support team. Really important reason for this. You may be using a certain family sort of protocol number for the vehicle, and it may have been updated for a new release of the K-Suite software. But if you read it on version 1, and now it's been updated to version 2, the writing may be slightly different to the file that you downloaded. So best practice, don't update the software or the firmware in between the reading and writing process on a vehicle, unless otherwise instructed by the support teams. Now it's completed. We can see we've got our Alientech Suite. We've got our options on there. It's showing us that we've got internet connection. The little symbol on there, sort of the Wi-Fi signal, if you like, in the top corner. If that's red, or a big sort of cross through there, it means you've got no internet connection. You do need internet connection to use the Alientech KESS3. It's a much simplified interface compared to the previous version. It's all on one screen. We can see on the left-hand side we've got our vehicles, support, news, and options. We're going to jump down into the options before anything else, just to show the options we've got in there. So in this case, we've got it in language and English. We've got legal notices, that's the sort of disclaimers about obviously the use of the tool itself. Version, and we've got updates. Now this is completely up to date, so we don't need to press the updates option on there. News will take us to Alientech's site to give us news about brand new releases. Support, that will take you to the Alientech dashboard as well. So this is where you can create a support ticket. So if you're already logged in, it will take you straight to it. If you're not, you'll need to sign in with your Alien ID and register the support ticket for the tool that you're using. So we're going to head to vehicles at the top. And this is where you're going to spend pretty much all of your time inside the software itself. We can see across the top of the screen, we've got an A to Z. We've got a car icon, a bike. We have a truck, HGV on there, sort of lorry. We also have tractor, which of course is for our agricultural. Might not be a tractor, might be a combine harvester or something else, but you get the idea. All of our sort of farm equipment and machinery that's supported is listed under that icon. Then we have a little boat at the end. That's for all of our marine applications, whether it's a jet ski or it's a big twin hull catamaran running big sort of diesel engines. They're going to be listed under the marine application if they're supported. The A to Z basically means everything that's supported is found under the one list. Now this simplified interface means that all we have to do is come down to the drop-down arrows underneath where it says vehicle make, just left click, and we can see everything in alphabetical order is listed there. Now of course we've got it on the A to Z at the moment, which means we've got a big list of every single manufacturer that's supported, by the way, for OBD and boot and bench all through one interface. So we need to narrow that list down to make our lives a little bit easier and to make the journey a bit quicker. So we're going to left click on the car icon. With that clicked, we could then use vehicle make, We can come all the way down to Volkswagen at the bottom of the screen here. Select Volkswagen. And we get every Volkswagen vehicle. As you can see, there's quite a few Volkswagens to select. Huge year range, model range, engine and ECU variants all supported in there. We can then try and filter a little bit more by going to model and from year. Now with this, I actually recommend you probably skip a step and jump across to the category over here first. The reason for this, it will shortlist the vehicles a little bit more, because if you look on here, we've got a couple of different Amaroks. We've got 1, 2, 3, 4, 5, 6 Beetles showing on the screen there. Now it might be your vehicle is between a listing that says 2012 to 2017, and there could be 3 or 4 different slight variations of crossover in there. So let's see if we can filter it down a little bit more. Go to category, and we've got the option for ECU and TCU. Obviously ECU, engine control unit, also known as PCM, powertrain control module. We've also got TCU, which is your gearbox control unit, or transmission control unit as it's known here. We're going to select ECU. So that's only filtered a few more out, but you can see the list, our little filter list, is increasing here. Fuel type. Well, this should help us filter even further. Let's select diesel. And we can see, I'm just going to clear the diesel one off for a second, either by pressing the X here, or the little X here to close it. At the moment, we've got 1,372 results. If I take that off, we've got 3,052. So just by selecting the fuel type on its own, we've just taken just over half of the listing out of the way. We've reduced it by over half. This is going to help us a little bit more. So now we go into model year. And we can see, just as the Beetle as an example was, it isn't a Beetle here, it's a VW Golf. We can see that the Beetle variant that was showing 6 on the screen has already dropped to 4. So it's making our list a little bit more manageable, easier to see. And we can drag this down now to Golf. And of course, Golf's going to be a large listing on there. And we've got a couple of options for Golf. Now, if you know the specific code of Golf that it is, so we typically run off sort of Mark 4, Mark 5, Mark 6, Mark 7 and so on. But you can see you've got 5G1, you've got BQ1 on there. Now this is a 2019 vehicle, so it stands to reason it should be under the 2017. So we'll left click on there, and we're greeted with this large list on the screen here. Now you may find that your vehicle, whilst it may be a 2017 model, and there's a listing from 2017, just because that's the year the vehicle's registered. So for example, in a UK it may have a 17 or 67 plate on there to show it's a 2017 vehicle. It may be that it was built even as far back as 2015. It may have stayed in storage for a while, waiting to be sold in a dealership, and then was given its new registration plates or license plates. So just because it says it's a 2017 vehicle, looking at the vehicle documentation, it may be a slightly older vehicle in terms of its build date. And it's the build date that's the important bit. If we're looking under the listing, as you can see here, from 2017 onwards, our vehicle may even say 2018 on its documentation for when it was first registered for road use, its license plate or registration number, etc. But it may well have been built in 2016 as part of a huge big production, and it just sat in a dealership. It may have been a bright pink model that wasn't the most desirable one and took a while to sell. So it may have pre-2017 control unit inside. It's important to take away from everything we're going through here that all of these options we're looking at are to try and help us find the correct ECU, or in this case TCU as well. This is the important bit of information. We're not going to find an EDC17 C64 ECU that is a VAG, Volkswagen Audi Group specific control unit, in a Mercedes-Benz C63. You may find EDC17 ECU types in Mercedes diesels, but the C64 is specific to the Volkswagen Audi Group. So it's that ECU type that we're looking for. That's the important bit. All this information here is a guide to try and get you to the right ECU. Of course, if you're on the wrong ECU, it's either not going to read or give you some sort of error, or maybe an incorrect ID on there. You ID the vehicle, it tells you, hey, I'm actually a different ECU. What we're trying to get to is the right ECU type. So you can see on there we've got, obviously, the Volkswagens down the side, Mark 7 or 7th edition. We've got the code for it, the BQ1, 2017 onwards. So it doesn't mean it has to be manufactured in 2017. It could be a 2018 build date on there. And we've got the 2-litre TDI Blue Motion in there, ED17 C64. We've got down here Delphi DCM 6.2. And then we've got a C74.
Now we actually know on this vehicle it's a C74. We know this through previously obviously trying to connect to the vehicle. We could go through now and try an EDC17 C64 and we're going to find we're going to get the wrong information back from the vehicle. If you do manage to get an ID, you're going to get information in there. Now this being a virtual read that you'll see in a second, you're going to struggle to get the correct original downloaded if you're on the wrong protocol. And even if you are on a C64 that's very close to the C74, when you try and download the original, Alientech servers should be able to detect you're on the wrong protocol. It's not going to get the full handshake on a C64 that it would on a C74. Some ECUs are so similar that when you have a full reading function, it's possible to get the data from the ECU, but it might be slightly the wrong size. A brilliant example of this is actually another Golf, Mark IV Golf, 1.8 turbo. So sort of one of the most popular cars for tuning that really sort of was a catalyst for the tuning industry back in the early 2000s, late 90s, early 2000s. That Mark IV Golf, one of the most tunable standard engines out there at the time, that 1.8 turbo had two different chips basically on the ECU, on the ME7.5. You had one that was effectively half a meg in size and one that was a megabyte in size. Protocol or family 38 and 39 were the two options. You could read the smaller chip on the bigger chip protocol because the communication path was still the same. It's just that it only downloaded half a file size effectively. So it is possible to read an ECU on the wrong one, but of course it wouldn't allow you to write back because of course the file size was incorrect. The software is pretty good at preventing these issues, but remember, it's not perfect. No software or tool in the world is. You have to double check that you are connecting to the right vehicle and the horsepower and settings, everything else match what you're working on. So in this case, we could check the engine code on the vehicle. So whether we're looking through CRLB or CRBC, we know this ECU is actually equipped with an EDC17 C74. The ECU's been out several times during training and demonstrations that we do as well. If you're unsure of the ECU, go and find it in the vehicle, look at the label on top, confirm the actual sticker on there. It will usually say, especially a Bosch ECU, will usually say the ECU type that it is. Of course, come back a step, check the engine code. The more information you can get from the vehicle first, the easier the reading process is going to be, because you're not going to waste time going through the wrong thing, trying to look at a Delphi ECU and struggling to communicate, because it's clearly not a Delphi ECU. Show up on the shortlist. We've only got 3 ECU types here. So I'll go on to the 74. And again, shortlists even more. So it doesn't matter whether we select the Blue Motion 6MT for manual or automatic. If we look across here at the family types, the protocol numbers, we can see it's the same, if you like, communication, the same language, 2979 for all of them through OBD. 1198 for service mode, that's where you connect to the pins on the loom connector of the ECU, and 705 for boot. That's where you have to physically open the ECU and connect to the circuit board itself. So it doesn't actually matter which one of these we select at this point, whether it's the 109 or the 148 horsepower, they're all the same communication path. Just click the top one in the list there, and we can press continue. Just before I do that, I'll show you the last option at the top of the screen, which is the engine code. We've just seen this here in the list. Again, you can shortlist based on the engine code. We do have as well search results at the top, so if we had none of these filters on, we could have just typed in EDC17C74 and it would have shortlisted every vehicle that has that in there. The only thing with that is it can get a little bit sort of overwhelming, because especially for something like the Volkswagen Audi group, we're then going to have every Seat, every Skoda, every Audi that's got that ECU equipped to it is going to appear in our list. So instead of 7 results as we've got here on the screen, we might have 277 results, for example. But it's a quick way to sort of pre-filter the information, if that makes sense. We'll press continue. And now we can see on the screen we've got our connection methods. So it's telling us OBD, bench, boot. It's telling us the status, they're all active. It's giving us the manual for communication, for connection on there, so we can see, well, what cables do I need? So before I even go out to the vehicle, I can check, do I need a special cable for this? Am I going to need to solder something if it's boot mode on there, etc.? The information is all there for you. It also tells me which function it's going to be for OBD. See the RD for reading, that's greyed out. This means this is a virtual reading. So this means we're going to do an ID. We're going to have the option for ID and writing on the screen, but no reading option on the next screen, because the reading is done as part of the ID. When we ID it, it connects to Alientech server and goes, right, I'm looking for a matching original. If it finds one, it'll allow you to download straight away. If it doesn't, not a problem. You may have to manually request an original from Alientech if you're using a master tool. If you've got a slave or client tool, then you just send it to your file provider, such as VIEZU Technologies, and the technical support team will then look for the original, make the tuning based on your requirements, and send it back to you. So just because it says VR in there, and if it doesn't find an original when you press the ID, don't panic. Doesn't mean there isn't an original, just means it may not be able to find it automatically on the system. You'll notice next to connection there's a little circle with a little eye for information in there. If you left click on there, it gives you a breakdown of all the sort of icons that are on the screen. But, well, it says there a legend. It's a key for the descriptions. So you can see the little exclamation mark in the triangle is a coming soon. RD is our reading, virtual reading for VR, and so on and so forth. Quite cool, and they're the clonable, so it tells you if the ECU is clonable or not. Patch, quite important, not for OBD at this point necessarily, but it is important to note. Patch functions available if needed. So this may be an ECU, it isn't in this case, but it may be an ECU you're working on, requires the ECU to be patched to enable OBD tuning. Some ECUs in the past used to require this. The Siemens PCR 2.1, using the 1.6 Volkswagen Audi Group diesel engine. Before you could tune that through the OBD, you had to effectively unlock the ECU. You had to apply a patch to the ECU on the bench through the actual boot mode, then later transferred to bench mode. And then the protocol was updated that you no longer had to do that direct to the ECU. You could just do it all through the OBD port as part of the reading and writing process. You've also got read passwords, so an unlock code can be required on certain ECUs. It's not very common, but some ECUs may require that. But all the information's there for you to read through. We need to click, and we can click anywhere on this sort of top row. You see it highlights it, puts a little dot in the box, so we know that one's selected. And we can then press continue, and it'll take us to the next screen. We've got an option to read the manual as well at this point. So do you know what? Let's check the manual. It's important we're up to date with the latest instructions. The beautiful thing about the Alientech suite being this sort of always online software is that you're not having to go and download megabytes and gigabytes worth of manuals and risk being out of date on one of the manuals. Something may have been updated that requires you to use, let's say it's boot mode, less connections. You don't need to solder to the ECU anymore. You can now just put one pin on and it does all the work for you. Whatever it may be. It's important that you're up to date with the instructions, and by being this sort of always online tool, because it downloads live the protocol that we're about to use, which is what it's about to do now, it's always got our up-to-date instructions, and it means the protocol is always the latest version of that protocol. Again, instead of having for you to go and do a software update, or you forgot to do one in the morning and your protocol's out of date and you may have had a new function released on it that could have made the reading 1 or 2 minutes instead of 10. So we've got on here ID available, reading not available, tells us virtual reading. So we're not going to have a reading button or option on the next screen when we actually go to communicate with the vehicle. We've got writing, and we've got one of the coolest features in the tuning world, which is recovery. So the Alientech KESS3, through the Alientech suite, is the only tool that has this built-in recovery feature. What this does is enables you, if something's gone wrong through the writing process, laptop battery may have gone. Always keep it uncharged just in case. But laptop battery may have gone. Someone may have disconnected the cable. Again, keep everyone clear of the vehicle when you're communicating with it. But it does happen sometimes. Power cut in the building, whatever it is. Something's interrupted the communication. It's errored out whilst writing. Maybe you didn't get full ignition too and it's powered down the ignition. Again, make sure you get full ignition too. But these things can happen. The recovery function does the same writing, but in a slightly different way. So instead of trying to start at, let's say there's 10 address points and we're tuning from 4 to 6. Instead of going back to block 4 and going, right, I need to try and recover from here, it will actually look at block 1 and then block 2 and block 3. And it will go all the way through the ECU for everywhere it can physically communicate and write to. It will check everything, and then when it comes across a problem, it will erase that block and then rewrite that block. So effectively, it's like the writing process, but instead of the writing just going in trying to adjust those tiny little bits that have been modified, the recovery is a little bit more thorough, shall we say, a little bit more robust in what it does. It's a longer process with the recovery function, but it tries to restore that ECU, it tries to recover that ECU by fixing any of the corrupted bytes and things that are in there. So really, really cool feature that is only on the Alientech KESS3. So some cool information in here. It tells us the cable that we may need to use. That's hyperlinked, so we could click on that. There is only one OBD2 cable. We don't need to go and look at that for this car. After completing the writing, it tells you disconnect from the KESS. So again, it's giving you some more instructions. It's giving you sort of a little bit of a rundown. Connect the KESS to the vehicle. Connect the KESS to the diagnostic port. It's straightforward, the information that's there. Okay. It is advisable if it says anything other than normal OBD2 cable, if it's not a cable you're familiar with, just click on the hyperlink, check the cable. Even if you've seen it 100 times, do you know what? Click on it anyway just to make sure. But we're going to close the manual now, and you can see we're now greeted with our ID, writing and recovery screen. Remember, there is no reading on there because this is a virtual read. So the next step to do is obviously go and connect to the vehicle. We'll see then our voltage come up because we've got our power stabilizer, our battery stabilizer on the car. We'll connect to our OBD2 port and we'll see the power reading in the bottom right hand corner. Again, another cool feature to help you monitor the power levels at the time. If you see anything below sort of 12.4, you might want to get a little bit concerned. Double check your connections on the battery stabilizer. You might not have a good earth on there. You might not have turned it on. It might be plugged in but not switched on. So double check those things. If you see 0 down there, well, you're not connected to the OBD port. No two ways around it. You're not connected correctly to the port. And if you see things above sort of 14 volts, again, you might just want to check your connections, check the mode that your power supply is on. It might be in sort of full charge or recondition mode. It might be giving a little bit too much to the vehicle. Typically, anything above really 13.5 is getting into that area where the ECU might actually shut itself down for communication, for writing, because it thinks the engine's running at that voltage. Okay, so you're looking between about 12.4, 12.5 volts, up to around about 13.5 volts. Is that sort of sweet spot for reading and writing to vehicles.
On the screen in the top left-hand corner, you'll see the selected information. So this is the vehicle we chose on the previous menus. So this is the Mark 7 Golf, this is the 2-litre diesel, we've got the engine code on there. We can see the engine model as well, protocol number, all sort of important information. On the right-hand side, we've got ID, writing and recovery. Now, this is important because this is a VR car, a virtual read car. There is no reading box. If it had the RD highlighted in bold black text on the previous screen, then this would mean that this vehicle is what we call a sort of traditional read and write car, where we would take a copy of the software through the OBD port from the ECU. In this case, we're doing an ID, which is then going to connect to Alientech's server, look for a matching original and download it from Alientech's cloud to our computer. These are actually great because they're a much quicker read and write process because it's the virtual download. The only difference you're going to see, as I said, with the read option is you'll see a reading box there. So the additional step you're going to take with a car that has a traditional read is you'll do the ID that we're about to carry out. Then after that, you'll press the reading button. That takes you through the same process that we're going to do on this car, just take a few minutes longer as it's actually taken a physical copy of the data from the ECU. Don't worry, when you've taken a copy of data from the ECU, you've only taken a copy. You haven't downloaded the information that's there and left the ECU blank. So if the customer needs to go or you need to move the car, it's in the workshop, blocking a ramp, whatever it may be, as long as you've finished the reading process and it's all completed, the file's saved, it's a copy of the data. You can disconnect everything from the car, start the car and position it wherever you want, or the customer can carry on their journey and come back later on in the day for the tuning. They might have an urgent appointment to get to. So we're going to continue now with the ID option. So you can see ID is highlighted at the top. We're going to press continue. Just noticing down in the bottom right hand corner we've got the battery voltage. So it's a really cool feature of the KESS3. You can see the voltage of the battery, so we know the stabilizer's working. We know we've got a good current through there. If you start to see anything sort of really below 12 volts, you need to check your connections on the charger. It may be you've got it connected but you haven't plugged it into the extension lead. Whatever it is, check the voltage. Anything below 12 is really too low, and at that point you need to check what's going on with the vehicle. If you get above sort of 14.4, 14.5, once the ignition's on, then you've probably got an issue somewhere else as well. Maybe the charger you're using, the stabilizer, is a bit too strong. You need to dial it down to a lower setting. Whatever it may be, just check the voltage. Ideal operating conditions are between about 12.4 volts and about 13.5 to 14 as a maximum. So we're going to select ID and press continue. You'll notice a sequence of messages appear on the screen saying things like check you've got the right family, check you've got the power connected, so the battery stabilizer, which we can confirm in the bottom right hand corner with the battery voltage that's showing down there. At the moment we've got about 14 volts, just over 14. It's a little bit high, but we haven't turned the ignition on yet. Of course, once the ignition's on, all the control units power up, there will be a slight drain or draw on the voltage and ampage through that battery. So that's okay at 14 at the moment. It's important you pay attention to these messages. Even if you've tuned hundreds of these cars before, this may have a slightly different ECU or slightly different software version in there, and what may happen is the sequence may differ slightly Don't go through it on autopilot. Don't just think, oh, ignition on, click the button and press OK. It might be telling you something important. Some BMWs, for example, require the seatbelt plugging in on the driver's seat and the hazards turning on before you read and write to the vehicle. So it's important, no matter how many cars you've tuned, whether it's your first or your 10,000th, always check the instructions that are coming up on the screen. Now it's asking us to turn the ignition on. Ignition 2, really important that it is ignition 2, not ignition 1. Sometimes with push button starts or key cards and push button start combinations, it might look like you've got ignition 2. Make sure you're familiar with the process for ignition 2 on that vehicle first. There's nothing worse than getting ignition 1. You might get a read through ignition 1 because you're only copying data at this point, but you repeat the sequence when you're writing. Ignition 1 is not enough power, basically. It's not the right operating mode to get the program to put the data into the ECU correctly. The dashboard may power down, and the last thing you want when transferring data, when programming data into an ECU, is basically the dashboard and the car to just turn itself off and go into sleep mode. So always make sure you've got ignition 2. It's really, really important. So it's starting its initial communication with the vehicle now. We'll see the voltage drop slightly just as the systems start to draw a little bit of power through there. That's not a problem. As long as it doesn't drop really below 12 volts, 12.4 ideally is the minimum, we're okay. We can see on there it's 13.9 now, so that's fine. The stabilizer's doing its job, everything's good with the car, and it asks us to turn the ignition off. Again, make sure it's completely off, not ignition 1, but completely off, all the lights off on the dashboard, and we click the OK button. You'll go through a sequence of these operation in progress. Now, it may be it's just opening the next part of the protocol. It may be saving a record of the actions it's just taken. It could actually be downloading data from the server. Just make sure you follow the steps through and let it carry out its actions on the screen. So once again, turning the ignition on to ignition 2, and we press OK. As we go through the Ecu Identification process, sometimes this can be quite quick. It's not necessarily computer-based. It's not even tool-based. It's car-related. So it's the speed of the communication on the car. You could have two cars, a BMW and a Mercedes, both with CAN bus systems. One may read quicker than the other, one may write quicker than the other. It's down to the ECU, the protocol, the wiring, everything else. So we can see on here it's got attention, ECU not identified, open a ticket, attaching log files to send to Alientech. Do you want to proceed anyway? It's not an uncommon thing to come up. It may just be something specific in this ECU has just sort of spooked the program slightly. It's going, I don't recognise that fourth character in there. It's not one I've seen before. The original could still be on the system, but think how many variables and different options of ECUs there are on the cars. Sometimes that may come back as a message. Turn the ignition off. Press OK. And again, it's giving us those attention messages. Make sure, for proper working on this family, to make sure it works correctly, make sure the stabilizer's on. And turn the ignition back on. Pressing the OK button. Now we can see we've got the ID. We've pulled up the hardware, the software, system, engine, even the chassis number. So it's definitely communicating with the vehicle at this point, which is fantastic. We've got the option to press Save ID here. Now, we mentioned there's a slight difference between this protocol and the read protocol. On the read protocol, you'd have the ID as a separate function, and then you can go into reading. Some people choose to go into reading straight away. This cool feature of KESS3 actually allows you to save the ID without having to go into the ID process at the start. So if you've got a protocol that says ID, reading, writing, recovery, and whatever else, you could just go into reading straight away. When it gets to this screen where it's done that first bit of communication, you can quickly save a snapshot of the ID to the computer and continue with the reading. Basically doing two processes in one, saving yourself a little bit of time and efficiency. We're going to press OK. And through a small sequence again now, what we should see happen is it'll connect to the server, and once it's connected to the server, it should allow us to download the original. You can see here we've got it as the save box. It's come up on our desktop, and we're going to call this the Viezu Training Golf. I recommend strongly whenever you're saving a file, call it what it is, so if it's an ID or a read, but put the registration number in front. You can use the chassis number, and that is completely unique to the vehicle. Private plates or vanity plates could change on the vehicle, but the chassis number should never change. However, 17 characters, it's easy to make a mistake in there. Use the registration or license plate of the vehicle as the name for it. So this is just an example, and that's why we're calling it Viezu Training Golf. So we can see at this point it's connecting to the server and it's trying to find a matching original. Unfortunately, it hasn't found one for this car. Don't panic. That can often happen. What we're seeing is that it's checked their server for a perfect matching original based on not just the ECU information, but the vehicle information as well. Remember, the VAG range has Audi, Volkswagen, Seat, Skoda, all encompassed under that brand. It could well be that there's a matching software upgrade number, a matching file for this vehicle, but it's listed under an Audi A3 or an Audi A4, for example, or something under a Seat or Skoda. So this can happen sometimes. Now, as a master, what you would then do, as a master file writer, you'd jump onto Alientech's database, you'd go onto their dashboard, go onto the original files, and you'd browse for the original file and find a matching original. As a client or slave tool user, you'd then send the file into ourselves, for example, to the Viezu desk support portal, and the technical team there would decode your ID. They would then look on the server for the matching original in the same way that any master file writer would, because remember, we are master file writers. We would then get that original, make the changes to the file that you require, code it up, and send it back to you. As a master file writer, of course, you'd download the original, then make the changes yourself before loading back to the vehicle. So don't panic when it says original file not found on the server. It doesn't necessarily mean it's not there, it's just it couldn't find it through the sequence it was going through. It doesn't happen every time, but it is a thing that can happen, just so you're aware. So we follow the sequence through on the screen. So it's going to ask us to turn off the dashboard. And once we've done that, we should be back at the main screen, and we can see the ID, writing, and recovery. So just before we jump into the writing, let's just talk about the other options that are on the screen quickly. We've obviously got the writing option, and we've got recovery as well. The recovery is a really cool feature built into the KESS3. What that allows us to do is write the file to the vehicle. It may be the tuned file, it may be an original file. If something's gone wrong, you're trying to recover the car back because it failed during writing. Customers been near the car, they've disconnected an OBD port. It does happen. Try and keep everyone away from the car whilst it's communicating. The recovery writes the file to the vehicle in a slightly different way to the normal writing. If you imagine your file is sort of this big inside the ECU, this is the area you've got to program back in. The normal writing is just addressing where the maps are, where the changes are. What the recovery does is just goes back a step and basically goes, right, I'm going to check the last good bit of data, carry on through a block at a time and do a slightly slower, more methodical writing process. So when it does find an error or corrupted block of data, it stops, erases that one block, rewrites it, and then carries on. The normal writing method is going in there and just making the small adjustments, making those modifications to the file quickly as it goes through. The recovery function is almost erasing a block at a time, as opposed to just making those individual changes. It erases an entire block and then reprograms it, basically to overwrite any faults or errors that occurred during the programming communication process previously. So it's a really cool built-in feature inside the KESS3 and inside the Alientech suite software. Now, providing you've got a matching original has been found on the system, or your master's found one, the file will then be created, or you as a master will create the file yourself, and then you're back to the screen here where we need to write the file to the car. So what we're going to do now is go through that process. Now you've got the original on your computer, you've gone through the modification process, and you've got your tuned file ready as well. As a slave or client tool user, you've sent your file off, you've sent the ID off to ourselves. The Viezu technical team have gone through the process, they've found the original, made the required changes that you asked for, so the performance file and whatever else sort of additional requests and requirements you had on there. File's been done, all packaged up, sent back to you, you've got it on your computer, you've saved it from your emails or from the ticket, and you're ready to write. So this is very similar to the ideal reading process now. Of course, we press the writing button instead, but the sequence of actions for ignition on, ignition off are going to be very similar. Always pay attention to the screen though, that's really important. So we're going to press writing, and we're going to press continue. And it's going to ask us for the tune file. It makes sense, it needs to know what file you want to write back to the vehicle. We're going to select the VW Golf GTD VPerf in this case. Remember, that's just an example. Your file, if it comes from us, will have the vehicle registration number and then the level of tune and any further modifications added on the end of the file name. I'm going to press open. Very quickly, you may just notice it on the screen there, it was checking to see if the original file's needed. And you may ask, well, why does it need the original file? We're putting a tune file on there. Well, especially with ID-only or virtual read protocols, the tool requires the original to basically do its balances and checks. It needs to check the checksum, needs to make sure it's all corrected. Remember, we've modified data, so it's a bit like a set of scales. We've put some more boost and adjusted the fueling. The scales are sort of out of sync. The checksum balances that equation. It's a simplified way of looking at it, but it's correcting the maths inside the ECU, that sort of security in there to make sure it recognises the data that goes in, making sure the maths balance effectively. It's asking us for the original file for comparison. If you select the wrong file, you could have serious issues with the vehicle. It could be so close that it goes through and does the corrections, but instead of this Golf, you've picked the other Golf in the workshop, which is why it's important you always label everything as the registration number, so there's no chance to get those mixed up. Okay, so to mitigate those issues, make sure it's the right original. Now, as a slave or client user, you shouldn't really come across this issue because this comparison is done at the master level. So we're doing that for you. So the Viezu technical team are coding the file up, comparing it against the original, packaging it up and sending it back to you to write back to the vehicle. As a master file writer, though, you will see this more often than not, and you need to make sure you follow the process through. Just double check. We're going to press OK. Again, the browse window comes up, so we need to select the original, VW Golf GTD original in this case, and press open. And it's going to do this comparison, that checking, it said compliance on there. Now, the beautiful thing about the KESS3 is this process is really quick. Compared to the previous model of the tool and other tools on the market, this is probably the quickest out there by quite a long way. This used to take a few minutes to do that processing, to do that comparison, literally seconds in this case. It will vary from vehicle to vehicle, of course. Different size files, different ECU types will require different calculation times on there. So we're just going to go through now, follow the instructions on the screen. It says again, checking about the stabilizer. It's all on there. We can check the power in the corner of the screen, got 14 volts down there. All is good. We're going to press OK, and we're going to go through to the next step. So now on the screen, it's telling us to turn the ignition on, check the connections, make sure everything's OK. Ignition back on. See our voltage has dropped slightly, that's fine. Our charger's on there, that's all good. It's starting communication. You can see the progress bar at the bottom of the screen. Different communication phases will require different lengths of time. Don't worry about it, it's just going through its process. Everything is all good. Asking us to turn off the dash. That's OK. Done. Now we may see a message pop up similar to the ID where it said ECU not recognized. That doesn't automatically mean there's a problem. Remember, it didn't recognize this ECU with the Volkswagen Golf combination in the Alientech database. So basically, because it hasn't seen this file come through a Golf before, it may pop up that warning message on the screen. Don't worry about it. We know the file's good. We've got the original from Alientech's server, or if you're a client or slave tool user, you've got the tune file back from your file supplier, such as VIEZU Technologies, and you're ready to write the file back on. So following the steps through, ignition back on. We press OK. Again, checking that voltage in the corner, 13.2, absolutely perfect. Within that operating area we said 12.4 to 13.4, 13.5. So we can see we've got on the screen now that message, as we just mentioned, ECU not identified, open a ticket, log and read files, proceed anyway. We're happy, we can proceed anyway, we've got the correct files for the vehicle, so we just follow the steps through. Turn ignition off. Again, make sure the stabilizer's on there. So I will just say at this point as well, we have already turned things like the aircon off, the headlights are off, all the ancillary systems are off on the vehicle. You will notice on some cars, and it's just down to the CAN bus system how it works, that sometimes the radio may turn on at certain phases. Don't panic, if it's on for more than a few seconds, just reach in and turn it off. But some vehicles do have the automatic start on the ignition too for the stereo to come on. So in this case, it's telling us to turn the ignition back on. So we'll turn it on, press OK. And we've got the ID on the screen again now. So similar to the ID and reading phase, we've got the ID popped up on the screen. It's just confirming it is talking to the vehicle. It's done that sort of initial handshake and it can communicate with it. We'll press OK, and now we get to the good part, proceed to writing. At this point, make sure, 'cause it's almost the point of no return, for want of a better phrase, make sure you've got the time you need on the car. It's not going to be moved in the next 2 minutes. You don't need to get in and get out of it to do all the work on there. This is the point where you're going to press OK, and when it does start writing, you step away from the vehicle and leave it until it's completed or until another prompt appears on the screen. So make sure it's in a nice, safe place. No other work needs to be carried out on it whilst it's doing the programming. The programming, the writing, is the dangerous part of the entire process. Okay, that's when you're physically changing data in the ECU. A bit like copying a file to a memory stick. Okay, if you take that memory stick out partway through, you end up with a corrupted file. This is the riskier part. It's not that it's dangerous, but it's just you really need to pay attention to this part. Make sure everything is nice and safe, no one touches anything on the vehicle. Proceed to writing. Make sure the selected file is correct for the car. ECU may be damaged if it's not. Again, it's giving you those messages. Are you sure you've selected the right file? You selected BMW M3. It's not an M3, it's a Golf. Make sure you've got the right data selected. And press OK. And again, it's going to go through a sequence of communications. We've got turn the ignition off. And we press OK. So we can see on the screen now it says turn ignition back on, so the ignition back on, and we press OK, and it carries on through the communication process. And it's a simple case of just follow the instructions on the screen. The writing may be a little bit longer than the reading process, because that's actually because it's programming the data as opposed to just taking a copy of the information out of there. So it's going through all of its preparation process. We can see in the corner the voltage is good, just above 13 volts, and we simply just watch the process go through. You see there the training file, the VW Golf training file, the performance file is going on, so we know we've got the correct file selected, and it will take a couple of minutes to program onto there. You can see we shorten this up slightly just for the video so you can see on there the programming. At 100% it's completed, but we wait until the screen has taken us back to the ECU communication completed menu. It's telling us now turn the ignition off, so we'll do that and press OK. Again, part of this operation in progress is saving the log files, the records of what's happened. So the tool keeps a memory of the work it's done. Ignition back on. Again, follow the instructions on the screen and press OK. Just storing its log files again now, keeping a memory of what it's done, the actions it's taken, the voltage during the writing process, etc. That's it, telling us to turn the ignition off. So ignition off, we press OK. ECU written successfully. Well, that's good news, that's what we wanted. So as we can see, that's the KESS3 OBD ID reading writing process completed. Hopefully you now understand how to use the tool, the importance of the instructions that are in there about obviously making sure the ignition is on and power cables are connected for a stabilised battery supply on there. It's important you follow the steps through. If you follow all the steps through there, you should have hassle-free tuning for as long as you're using the software. Thanks for watching, everybody.